Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video, we are covering CCNA CyberOps, Chapter 11, Security Monitoring. And this is our section 11.2, Log Files. Upon completion of this section, you should be able to explain the type of log files used in security monitoring. For example, the end device logs or server logs and so on. Describe the type of data used in security monitoring. For example, five different types of data that we have, like session data, what is transaction data, and so on. And the last section is to describe the elements of end device and network device log files. Section 11.2.1, Type of security data. The first type of data that we're going to talk about is called alert data. Alert data consists of messages generated by the intrusion prevention system, IPS, or intrusion detection system, IDS, in response to traffic that has violated a rule or matched the signature of known exploit. A network intrusion detection system, such as Snort, comes with already pre-configured rules for known exploits. Alerts that are generated by Snort, for example, they are readable and searchable by applications such as Squill, which are part of the Security Onion suite in network and system management tools. Now, Squill, we're going to talk a lot more in chapter 12. We can actually, even in there's a lab to do in Squill, as well as we're going to talk about ELSA. So this picture that you see on the screen is taken from Squill, which we're going to see it a lot more in chapter 12. Session and transaction data. Now, session data, it is record of conversation between two network endpoints. This usually is between the client and a server. Session data is about the session, not what the data has been retrieved and used by the client. Session data will include identifying information such as 5 tuples of source and destination IP address, source and destination port numbers, and IP code for the protocol in use. For example, the first is we see the timestamp. Timestamp in Unix format. Now, we need that timestamp to normalize it to something that we can understand it. But this is the timestamp first, then the unique session ID, for example. Then we have a originating IP address of the host originating the session, the port of that host, the IP address of the host responding to originating host, and the port number. The protocol, the transport layer protocol for that session, service, the application layer protocol, duration, how long it was the session for, the originating bytes sent, the responding bytes received, originating packets, how many packets you sent and you have received. All this is a session data. Just for example, say that user has opened the session to a local database. That's all we know, okay? A user, what is the IP address of that or end device? What is the port address of that end device? What protocol they used? What the destination IP address and port number? Now, that's different from transaction data. The transaction data consists of the messages that are exchanged during the network session. The transaction can be viewed in packet capture transcripts. For example, imagine the end device went to the server, opened the database, and that's just the session. But if that device has actually changed something on that database, that has happened as a transaction. So for example, like a get message or set message, these are transaction data. Device logs kept by servers also contain information about transactions that occur between the client and server. The transaction representing the request and replies would be logged in access log on by the server or by a network intrusion detection system like Bro. Full packet captures like Wireshark. Now, the difference between the session and transaction and full packet capture is that full packet capture is going to have everything. It's going to have the session that has opened, plus whatever the transaction has happened in there, as well as everything else. Now, it has the most detailed network data, and that is generally collected. But the problem is, because there's so much detail, They are also the most storage and retrieval intensive type of data used in network system management. The familiar tool that we know here is a Wireshark that is very popular for viewing full packet captures and accessing the data associated with the network conversations. So we have a session data, end device opened the server, this time, this IP address, this destination IP address, this source port, destination port, protocol. Transaction, what they changed, so the two type of data. Then we have a full packet captures, which is going to have everything. The next one is statistical data. Like session data, the statistical data is about the network traffic. From these analysis, conclusion can be made that describe or predict the network behavior. So statistics can be used to characterize normal amount of variation in network traffic patterns in order to identify the network conditions that are significantly outside those ranges in the effort to detect anomalies. So for example, say that we taking the statistical data, this much data is actually not just what kind of data, just how much data is actually going. We can even go in depth and look at with NBAR what kind of data or NetFlow and find out what are the statistics of our network, what type of how much data we are sending at what time and so on. So when something changes on that behavior, we can predict there's something, well, maybe there's intrusion or something like that. The next section, 11.2.2, end device logs. The first that we're going to talk about is host logs. Now, host-based intrusion prevention runs on individual hosts. HIDS system can use agents to submit logs to management servers. So some of the popular host logs that we have is OSSec. This is open source, includes a robust log collection and analysis functionality. The next one we have is Microsoft Windows, for example, includes several methods for automated host logs collection and analysis. So for example, if you see here, Windows logs, so it opens it, Windows will collect all the logs and we can view them from the event viewer. And the Windows logs we have, for example, security, setup, system, application, and forwarded event. But most important, it will be like security and the system to look at. Tripwire, a host intrusion detection system for Linux, includes similar functionality. Host logs, Windows events are identified by the ID number and a brief description. For example, if we see an error on the Windows logs, an error is an event that indicates a significant problem, such as loss of data or loss of functionality. For example, if a server fails to load during the startup. A warning is an event that is not necessarily significant, but may indicate a possible future problems. For example, when the disk space is low. So for example, if we see an error, means something terrible has happened. Warning, well, it's about to happen. And then we have an information. Information is an event that describes the successful operation of an application, driver, or services. For example, when network driver has loaded successfully. Then we have a success audit. There is an event data that records an audited security access attempt that is successful, and failure audit. For example, an event that records an audited security access attempts that fails. For example, if we say, okay, we want to log anyone that's trying to log on to our device or machine. We have failure audit. So we have anyone that tried to log in but you couldn't, that's a failure audit. But if we want to success audit anyone that has actually logged in, has had success to log in, then we'll see a log for that. Syslog again. Now we looked at the Syslog on previous lesson, but one of the most used protocol for event notification, which is defined in RFC 5424, it is Syslog. The Syslog protocol specifies three main entities. We have the originator. This entity generates the syslog messages. For example, a router, server, switch, all of these can be the originator. A collector, the entity that receives information about an event in a syslog format. For example, a syslog server can be the collector. And relay, an entity that can receive a message from originator and forward them to other relays or collectors. So we have three main entities: originator, the ones that create the message; collector, the ones that's receiving the message; and then the relay as well. Two additional concepts that are not part of RFC but are commonly used are the facility code and severity code. Now, facility code, if you look here, there can be now the facility code indicates the system, process, or application that has generated the Syslog. And then we have a severity code. Severity represents how severe is that message. And we have from integer numbers from 0 to 7, 0 being the most severe. The Syslog, the header of the Syslog message contains, among other things, the following important information. For example, we have the priority. What is the priority of this Syslog message? The priority is obtained by combining the numerical code of the facility and the severity. The formula to obtain the priority is, for example, the facility times 8 plus severity. For example, message with the facility code of security authorization message code 4 and the severity code of critical code 2 will have the priority of 34. So 8 times 4, 32, plus 2 is 34. So we have a severity, how severe it is, and facility, who's generated that message. Then we have something else we have in there is timestamp and host names, for example. Server logs. Server logs are an essential source of data for network security monitoring. Network application servers such as email and web servers keep access and error logs. Especially important are DNS proxy server logs, which document all the DNS queries and responses that occur on the network. Two important log files to be familiar are Apache Webserver access logs and Microsoft Internet Information Services IIS access logs. So this is one log for Apache Webserver. So as you can see there, we have a client IP address, client identity, user ID, and this is a log will come up, this type of log that will come up from Apache log servers. Security information and event management and log collection. Now, security information and event management is a specialized device or software for security event management. It does increase the normal log collectors functionality by providing log collection, normalization, aggregation, correlation, and report capabilities. For example, log collection. This includes receiving information from devices with multiple protocol and formats, storing the logs, and providing historical reporting and log filtering. Then we have a log normalization. This function extracts relevant attributes from log received in a different format and store them in commonly data model or template. Like we saw early on that we saw a timestamp, it was in different format. We don't understand it, but security information event management will be able to display them in the correct format or something that we can understand. Log aggregation. This function aggregates information based on a common information and reduces duplicates. Log correlation. This is probably the most important function of SIEM. It refers to the ability of the system to associate events gathered by various systems in different formats and at different times and create a single actionable event for the security analysis or investigators. Then last one is reporting. Event visibility is also key functionality in SIEM, or security information and event management. Reporting capabilities usually includes a real-time monitoring and historical based reports. Now section 11.2.3 network logs. First, TCPDUMP is command line sniffer or analyzer. TCPDUMP is an open source packet capture utility that runs on Linux and Mac OS X system. It does provide a good capability for capturing traffic to inform a specific host. TCPDUMP command line tool is a very popular packet analyzer. This is very, very similar to a Wireshark that you saw, but Wireshark is GUI while TCPDUMP is in command line. NetFlow is a Cisco technology that does provide visibility into all network traffic that traverses a Cisco supported device. Cisco invented NetFlow and is a leader IP traffic flow technology. So NetFlow, it's only for the Cisco devices. NetFlow was initially created for billing and accounting of network traffic. There's also Internet Protocol Flow Information Export, IPFIX, which is a network flow standard led by Internet Engineering Task Force. It's pretty much based on Cisco NetFlow version 9. Cisco Application Visibility and Control combines multiple technologies to recognize, analyze, and control over 1,000 applications. Cisco AVC uses existing Cisco network-based application recognition version 2 and bar 2 to provide deep packet inspections, technology to identify a wide variety of applications within the network traffic flow using layer 3 to layer 7 data. Cisco application visibility control includes an embedded monitoring agent that is combined with NetFlow to provide a wide variety of network metric data. Thank you for watching chapter 11 videos. Please have a look at my other videos and don't forget to subscribe. Bye bye. This has been Astrid Krasniqi. Bye bye.